Thanks very much for the opportunity to be here again. I really love coming to Tassie. There's plenty of things happening down here, and exactly what you said, Minister, about the connection with people. And I think there's always good events going on in Tassie, and everyone sort of kicks in together. And I think it really tells on the sort of level that the horticulture industries are at in this district. And I see that as I travel around, that this area certainly pulls its own weight. I'm going to talk about a sort of key technologies that I've seen, I guess, in precision ag, and the benefits that it might have in horticulture. I guess there's so much technology. You know, James and I have just been over to the US looking at the World Ag Tech Summit, and I tell you what, there is so much stuff coming in this ag tech space. It's sort of out of control. The US is spending so much money. All of a sudden, it's the new kid on the block, basically, and there's so much stuff hitting the deck, and the money that's being spent is unbelievable. So if you think you've got a tech overload at the moment, you've seen nothing yet compared to what's coming. And I think it's going to continue on for a while yet. But you know, I started working down in Tassie many years ago with the controlled traffic and the auto steer stuff, and that's really led us to some of the newer technology like drainage mapping and looking at subsoil constraints and imagery and those type of things. So I'm going to quickly flash through these things, and I'm going to spend a bit more time in my concurrent session digging into some more detail, if you like, about those sort of specific technologies that you're interested in. Let's start off with elevation. As you know, waterlogging is probably one of your key drivers of productivity down here. That's not new, but I tell you, the technology that's sitting in your tractors now is actually very useful to fix up these drainage problems that you've already got. So the other good thing is that, and Darren's going to talk a bit about this at the moment, you guys are really spoilt down here for data. Absolutely spoilt. Right? You got no idea how good Darren's crew, it's sort of world-leading stuff, and he won't blow his own trumpet too much. But I tell you what, the data that these guys have produced is well-renowned. Even stuff on the mainland doesn't come close. So you've got a stack of data, and one of those is LiDAR. LiDAR is a laser scanner that's been done with an airborne platform over most of your growing areas in Tassie. And I just heard yesterday that the statewide, you're going to get a statewide coverage of this technology as well. Now LiDAR is very, very accurate vertically. So we're talking a few, sub 10 centimetres vertical accuracy. There's an example of a farm just down the road that we did some work on a few months ago, and we just grabbed the data straight off the site that Darren will talk about, and we were able to produce a drainage plan based on that data without any no ground survey at all. The thing that we can do then is do some pretty cool analysis. All right, we can throw that into 3D and have a look at how that landform performs. That's not the same paddock. This is a paddock from New Zealand actually, but it will. You can actually throw that into 3D and then start looking at where is the ponded areas in that field. So without even being to that paddock, you can tell how much water is going to sit in that field at any particular time. And that's the sort of level of technology that we've got now to do that. You can then look at the flow paths of that. Where's that water likely to go? Where can you cut some pretty strategic drains so that you can actually get that country to drain properly? So there's a couple of different levels here. You can either do a full land levelling service, and certainly Bill and that will talk about that in the concurrent sessions. But some strategic drains might be a simple answer to fix those problems. And this flow path analysis, like you see there, actually determines where that water is going to flow. So you got the data here, you've got the technology, you've got plenty of skilled people around. You just need to get in and have a crack at it, because it is achievable to actually fix these problems. The other good thing about this sort of data, this is an example from Queensland, where we looked at run direction, and it's very important here, obviously, with your beds, your raised bed farming, to actually look at which run direction is going to be the best for the paddock. And in this case, you can see if we ran the rows north-south, the blue areas is where the water would lay, right? If I turn that around, go east-west, it changes completely where that water's sitting in the field, all because of those raised beds or wheel track direction. So it's very important that you include the run directions in your planning, because it will have a big impact over and above the actual natural topography. So that's really important. Obviously, when you've got pretty steep slopes in the North Country here, it's not too bad. You're pretty straightforward. You're going to just run up and down the hill. But when you get into these complex landscapes like around here, you really need to look at run direction as well as your natural topography. And that sort of technology can help you do that. The other cool thing is, this is another farm from New Zealand. This guy had a problem with erosion in this paddock. That's the topography. So the red's the highest part of the field and the blue's the lowest. So it's just a pretty steep field. If we look at the runoff now, this is not waterlogging. This is the speed of the runoff coming off the land. Okay, so I'm talking about velocity of runoff. In this case, with no raised beds or furrows, that's the runoff. And you can see, well, you can't see probably. It's pretty hard to see. Basically, it's not that bad of an issue in its natural state. As soon as we add a furrow, in this case a 1.5 metre bed with a 20 centimetre deep furrow, which is pretty typical sort of raised bed sort of farming system for around here, you can start to see the velocities increase. And that's because each furrow now is carrying its water down a confined area. And it highlighted straight away where those higher risk areas are in the orange. If I increase the bed width to 2.5 metres, which means more water is going into those furrows, each furrow, then the velocity is going to increase again. So now we've got those red areas becoming quite red and up into the erosive velocities sort of phases. So anything up to that metre per second is 0.7 metres per second really gets erosive velocity. So we'll start to see soil erosion in that particular case. And again, this data is just straight off the tractor auto steer or off your LiDAR data. We've just run a scenario changing the bed direction. It's pretty straightforward. If we look at changing direction, it's exactly the same field. If I turn it from sort of east-west to north-south, all of a sudden the erosive areas of the landscape now are in that northern part of the field. So just by changing that run direction in these landscapes, even though they're pretty steep, can have a big impact on how your farm performs and where the erosion is going to be. In this case too, I want to leave you with just a bit of a thing here. If we add ground cover into this, and I know most of our systems are tilled, right? I get that. It's not very easy to do no-till in vegetables. Actually, it's almost impossible. But if we add ground cover to this scenario, that's what happens to the velocities. So if we go back to the 1.5 metre bed, you get velocities like that. With some ground cover, you can reduce those velocities. So it's really important to look at the whole system here, not just run direction, but ground cover as well. And this is what this farmer did in New Zealand. It's Wilcox's in New Zealand. We just put some strips across there, a bit like what you've done here. It didn't really solve the problem, but it sort of slowed some of the water down. But I guess the key thing is you can do a lot of this technology, a lot of this analysis without leaving the office, essentially, before any rain falls. Let's move on to yield monitoring, and I'm not going to steal Josh's thunder because he's got some great slides on yield monitoring, but one of the key things that we did in Queensland back quite a few years ago was look at yield monitoring in horticulture, because the industry, beyond what Simple have done down here, there was almost no yield monitors in Australia at all in horticulture, especially in root crops. So we put some of the first yield monitors in Queensland about 4 or 5 years ago, and Josh is going to talk a bit about what his experience is, but I thought I'd put up this one slide, if the slide thing works. This is a profit yield map generated from a carrot. It's a profit map, generated from a carrot yield map. So this is the first carrot yield map ever produced in Queensland, and we turned it into a profit map just by simply taking away the variable costs, timesing it by the value of production or the value of the carrots. And you can see the sort of yellow areas, the gross margin was between $5,000 and $10,000 per hectare, right? 5 to 10 grand he made on those yellow areas. In the green areas he made between $10,000 and $20,000 a hectare. But in the blue areas he made $20,000 to $30,000 a hectare. Now that's 1/4 of 1 centipivot. A 6-fold variation in profitability in 1/4 of 1 centipivot. And what do you think's driving that? What's the main factor there? Well, there's actually two, because I actually mapped the soils on that. The soil's one of the impacts, but the other big impact is water. right? You can see the blue areas are actually yielding better because they're under irrigated. So it's very important to actually know where to locate your moisture probes and where to put those sensors to actually get the right information to make sure you're doing a proper job. Because in this case, he's lost a packet load of money, all because he's under irrigated. So I guess this is, if he's not going to change anything based on this, I don't know what will change him, really, to be honest, because that really shows that there's a lot to be gained in very small areas just by getting the basics right. Let's look at some in-crop imagery and sensors. I'm going to go into this in a lot more detail in my concurrent session. The web-based app that we've produced provides real-time satellite imagery to farms anywhere in the world, and it's for free. It's 10-metre resolution, and this is a paddock just north of here. The good thing about the new satellites that are coming over now, we're getting them every 2 or 3 days in northern Tassie. You're lucky in Tassie that you're so far down south, you actually get overlap of satellites. So up in the mainland, we're getting them every 5 days. This is every 2 or 3 days. So get on and use this because it's a really good tool to start you understanding the variability that's going on in your paddocks in real time. So this data is captured at 10:30 every second morning, and it arrives in this about 12:30. So you're getting it basically in real time every day. So get in and have a use it and start to ground truth based on this sort of information. We've also done a lot of work, and John's done a lot of work down here as well, John McPhee, with crop sensing. This is a tomato crop in North Queensland. It's a long way from here, but I tell you, we just decided, could we put a satellite on the ground? And that's basically what this thing is a satellite on the ground, on a quad bike, and running up and down the rows of tomatoes. And we're thinking, well, we don't really know what's going to come out of this because we don't know what the value is. But when we had a look at the data and when we stopped at individual plants, the plants on the left there were very healthy. The plant on the right showed a very low NDVI reading, very low health reading. Turns out they're all the diseased plants. So we were able to pick up the disease in the paddock before the agronomists sort of really understood that there was a big disease problem there. So some of these tools could be used in real time as you're doing your normal machinery activities, and this is what the next one shows. This will suit your vineyard. This is a vineyard in South Australia where that guy put a crop sensor on his tractor and drove it up and down every road just every day, part of his normal spraying activities, right? We then matched that back to the disease. There's a disease dieback in South Australia that's quite concerning. We actually matched the NDVI readings coming from the sensor back to the disease, and sure enough, there's a straight line correlation between the two, and we're able to map disease dieback in the orchard. Now, in the vineyard. So the key thing here is so what? The reality is that they're looking at replanting these blocks after 50 years of growing grapes. So they need to know when the critical cut-off level is. So when do we actually remove the vineyard and replant? They need an assessment of that independently because it's going to cost a lot of money. So these tools can be really used in a lot of cases, same sort of technology, but it's very important they're ground truth. Let's have a look at some soil mapping, and you guys have probably done a fair bit of this sort of stuff down here, but EM's probably one of the best tools. If you have gravelly soils, and a lot of these soils I know do have some gravels in them, then it's better to use something like a gamma radiometrics, which is a whole different machine altogether. But EM's very commonly used machine across the world. It penetrates about 1.5 meters down into the soil, and it gives you a really good indication of what's happening below the surface without doing any physical ground contact. Now, this is an extreme example, but in these pivots here, one side of the pivot was complete sand, and the other side was complete clay. But the grower knew that, but this helped to delineate those areas, if you like, so we could treat those areas separately. And the sands were acid, and the clays were alkaline. They needed gypsum, and the sand needed lime. So completely different soil types. But coming back to the irrigation point of view with this, I mean, where do you put your moisture probes? You know, you're going to need to understand the base soil variability to where to put the moisture probes, and also if you're going to do vertebrate irrigation, and I'm not going to steal Joe's thunder because he knows a lot more about this than me, but if you're going to do vertebrate irrigation, you've got to understand two things. Correct me if I'm wrong, Joe. One is you've got to understand the infiltration rate, and the infiltration rate on sand and clay is going to be completely different, right? And the second thing you understand is how big the bucket is. So the sand is going to hold about half of what that clay holds in terms of moisture content. So they're the two things you're going to want to know before you start stuffing around variable rate irrigation, because you get yourself into a lot more trouble than what it's worth unless you understand those base soil differences. So really important layer. You've got plenty of resources down here to collect this data for you. So I'd encourage you, where you have specific problems, specific paddocks, so you have soil, inherent soil problems, get an EM done. The other thing that we've done a lot is variable rate gypsum and lime. Don't throw away grid-based soil sampling. I think you've got a great lab just up the road. If you pick and choose the things that you really want to look at, like pH, like phosphate, then you can grid sample quite cost effectively here. Okay? And you can build a map quite quickly. In this case, this was in North Queensland. It's a red soils, just like you've got in Northern Tassie. 25% lime saving just from doing some grid sampling. Didn't really cost them that much, half a pivot, So there is some savings to be made in some of those key inputs to get those soil balances right. So I encourage you to even don't throw variable rate out the window. I just want to briefly touch on a couple other bits of technology, and then I'm happy to go into detail in our concurrence. The other thing I guess there's a lot of stuff coming, like I said at the start, but there's really 4 key segments that are coming. There's the sensors in the IoT type world. There's heaps coming in that space. There's the robotics and machine automation. You're going to see a lot more working in that space. Smaller machines. We've already seen some of that up the road in some of the berry farms using robotics. UAVs fit into that camp. There's also a lot of data analytics and big data management. Now, that's been a big buzzword up until now, but I think that the tide's turning in us understanding a lot more about our paddocks once we have a lot more data, and that's coming, and I'll show you in a minute. And obviously protected horticulture and agriculture is really booming across the world. There's a whole heap of new machinery devices to track machines. I mean, if you're all green or red or yellow or purple, whatever colour you are, then your machines are going to be connected. So every tractor now has a SIM card in it. Basically, it's connected to the internet. But if you've got older machines, then you can plug these types of devices into the CAN bus, which will basically thieve all the data off the tractor and send it into the cloud, and you can access that from anywhere in the world. There's one there, Farm Mobile. There's another one I saw in the US the other day. Little tiny device, only this big, actually will track almost any piece of machinery, bins, whatever you want. So there's heaps of this stuff coming. There's also another piece of technology where we're looking at implementing as well, which takes data from machines and pushes it back to machines remotely, so we don't have to pull data cards and all those crazy things we used to do a lot of. So I think there's going to be a lot of movement in this space of machine connectivity as well as sensors and other things. The other bit of cool technology which I've seen, and there's a lot of work going on this, is green on green technology. So everyone's seen weed seekers, weed ITs, weed seekers. That's good technology, should be used in a fallow situation. But what's coming is green on green, which means it'll detect weeds in crop and spray those weeds independently, and will self-learn basically. So I'm talking to some robotics companies at the moment that are actually telling me they can detect, say, it'll drive over a field and it'll say there's 4 different types of weeds in that paddock. It doesn't know what the weed is, but they know there's 4 different types. Then you can start selecting which products you want to apply to those specific weeds. And that's really exciting technology, because we're in the era of so much herbicide resistance and control measures are becoming more and more difficult. So I think it's a really good technology to hit now, and with the advent of robotics coming, that will really improve our ability to deploy this type of technology, because it's going to need to be fairly slow in the first instance. This stuff is particularly, this one here is being commercialised by AgriFac, which is, I don't know if you've got AgriFac sprayers down here yet, but they're probably not really suited to Tassie, being 120 foot wide. No, probably not. But they're huge, 6,000 litre sort of tanks. But this sort of technology is coming, right? So there's some really good stuff. I'm going to leave you with one last slide, and my time's up. But this is a sobering thought. This is the this is some smart person. BI intelligence, they call themselves. It might be BS intelligence, I don't know. But someone smarter than me has worked out that within about 15 years, we're looking at about 4 million data points per farm per day. 4 million data points per farm per day. Now, we've got a couple of questions to ask about that. Is who's collecting that data? Where's it going? Is it being used against me, or is it going to help me? And who's benefiting from that? I'll just leave you with that thought. Thanks again for inviting me. Thanks.